All right. So now let's learn how can we get the adjoint of any matrix. So here we have a matrix A, 3 by 3 matrix. And to get the adjoint of this matrix, we have to create another matrix as you can see here. And we have to find out the cofactors of each element of this matrix A. And then we have to get the transpose of that matrix. Transpose, this is the symbol of transpose. Transpose means we have to interchange the rows and column. Okay. So first of all, let's find out the cofactors of each element. So for that, uh, cofactor of each element means we have to get the cofactor of 1, 3, 3 and all those, right? And we will write these cofactors on their corresponding positions in this new matrix. Fine. Here. So here we will write the cofactors. So now see how can we get the cofactors of 1 first of all. To get the cofactor of 1, we have to exclude the row and the column in this 1 is present. That means we will be excluding the first row and the first column, right? And rest of the elements we have to consider. So to get the cofactor of 1, we will write minus 1 raised to the power the sum of row and the column in which 1 is present. So this 1 is present in first row and first column, right? And it will be multiplied by rest of the elements, like 4 times of 4. So 4 times of 4 minus 3 times of 3, right? So it will be minus 1 raised to the power 2 it will be. So this will become 1 and it's here 16 minus 9, that is 7, right? So the first element will be 7 here. Now let's get the cofactor of second element, that is the cofactor of 3. Again, this 3 is present in first row and second column. We have to exclude this first row and second column, and that means we are going to include only these two elements and these two elements, right? So the cofactors of 3 will be minus 1 raised to the power, in which row this 3 is present? First row plus second column, right? And then 1 times of 4. So 1 times of 4 minus 3 times of 1. So this will be minus 1 raised to the power 3 will be minus 1 only, minus 1, and this will be 4 minus 3, which will be equals to minus 1. Okay, so the second element will be minus 1 here. Now let's get the third element, third cofactor. So to get the third cofactor, we have to get the cofactor of this 3. Again, we are excluding the first row and the third column this time. So we have to consider this matrix. Now for cofactor of 3, we will write minus 1 raised to the power first row third column, as 3 is present in first row and third column, and it should be multiplied by 1 times of 3 minus 4 times of 1. So this will become 1, 3 minus 4, which will be minus 1 again. So the third element will be minus 1 again. Now let's get the cofactor of this one, which is present in second row and first column. So we have to exclude the second row and the first column. So the cofactor of 1 will be minus 1 raised to the power second row plus first column multiplied by 3 times of 4, 3 times of 4 minus 3 times of 3, 3 times of 3, right? So it will be minus 1 and 12 minus 9, which will be equals to minus 3. So this second row first element here, it will be minus 3. Let me write it properly. Okay. Now to get the cofactor of 4, now you tell me which row and the column we have to exclude. We have to exclude the second row and the second column. So the cofactor of 4 will be minus 1 raised to the power second row plus second column, multiply by 1 times of 4 minus 3 times of 1. So it will be 1, 4 minus 3, which will be equals to 1. That means here we will write 1. Now the cofactor of 3. So we will exclude the second row and the third column, and we'll consider only these two elements and these two elements. So for the cofactor of 3, this one 3, we will write minus 1 raised to the power second row third column, and then 1 times of 3 minus 3 times of 1, which will be equals to minus 1, 3 minus 3, which will become 0. So here we will write 0. And then the cofactor of last row 1. So again we have to exclude the third row and the first column. So for the cofactors of 1, we will write minus 1 to the power third row first column, multiply by 3 times of 3 minus 4 times of 3. 4 times of 3. So it will become 1 multiplied by 9 minus 12, which will be equals to minus 3, right? So here the next element will be minus 3. Now let's get the cofactor of this 3. So again we have to exclude the last row, third row and the second column, right? So for the cofactor of 3, we will write minus 1 raised to the power third row second column, multiply by 1 times of 3 minus 3 times of 1, which will be equals to minus 1, and here it will become 0, which is 0 again. So it's 0. Now the cofactor of the last element, that is 4, we have to exclude the third row and the third column. That means we are going to include only these 4 elements. So for the cofactor of 4, we will write minus 1 raised to the power third row third column, right, multiply by 1 times of 4 minus 3 times of 1, which will be 1 multiplied by 4 minus 3. So it will be 1 only, right? So the last element of this matrix is 1. Now we got this matrix. Now we have to get the transpose of this matrix. Okay, so the adjoint matrix of matrix A will be, okay, so how can we get that matrix? For that we have to interchange the rows and the columns. That means the first row will become the first column, second row will become the second column, and third row will become the third column, right? So let's do it. First row is 7 minus 1 minus 1. So this we have to write in first column. So 7 minus 1 minus 1. Now what is the second row? Minus 3 1 0. So let's write it in row and second column. Minus 3 1 0, and the third row is 3 0 1. So it's 3 0 1. Okay, so this is the adjoint matrix of matrix A. Okay, hope it is clear. All right, now we had seen in last video that like to get the inverse of this matrix of matrix A, what we had to do, we had to okay, for the inverse of any matrix, what was the formula? Adjoint of matrix A over determinant of matrix A, and we had seen in last video that determinant of matrix A was 1, right? So this A inverse in this particular case will be equals to the adjoint of matrix A. Okay, so whatever you got over here in this matrix will be the inverse of matrix A as well, we can say, right? So let's write the same matrix as the inverse of matrix A. 7 minus 3 minus 3, the first row. Okay, so here A inverse will be equals to 7 minus 3 minus 3, and what was the second row? Minus 1 1 0, so it's minus 1 1 0, and what was the third row? Minus 1 0 1, so minus 1 0 1. This is the inverse of matrix A, so this will be your answer.